Let's take a look at some problems involving trapezoids. So a trapezoid is going to be a quadrilateral that's going to have exactly one pair of parallel sides. And the sides that are parallel, we're going to go ahead and refer to them as bases. And then the ones that are not parallel to each other, the non-parallel sides, we're going to call them legs. So we have a special type of trapezoid here. We have an isosceles trapezoid. So when we have an isosceles trapezoid is when the legs are congruent to each other. And then diagonals of trapezoids are going to be congruent to each other, just like they are in rectangles and squares. Okay, so on this problem, it's asking me to find the measurement of angles S. From what I can gather from this diagram, I know that my legs, which are the sides that are not parallel to each other, are congruent. That means that I have an isosceles trapezoid. And if I have an isosceles trapezoid, I'm going to go ahead and apply the properties for it. So let's go ahead and take a look of what we know for isosceles trapezoids. So we know that the base angles are going to be congruent. So let me go ahead and mark that on my diagram. All right, now that that's marked, let's go ahead and find out the measurement of the angle that I'm looking for, which is S. So these two angles are opposite to each other. And unlike a parallelogram, when you have opposite angles in a isosceles trapezoid, these are going to be supplementary. Meaning if I add the two measurements for the angles, it should give me 180 degrees. So let me go ahead and fill in some information that I have here. And then if I subtract 63 from both sides, then I get the measurement of S, which is 117 degrees. So that's one way of looking at it. I'm going to go ahead and do it two different ways just to give you different strategies of finding this angle here. If you just want to skip to the next problem, go ahead and just skip this part here. This is just a different way of doing it. So we know that we have a quadrilateral, right? So if I add all four angles, it should equal 360 degrees. And we can apply this strategy when we have an isosceles trapezoid only. Because we have that the base angles are congruent. All right, I don't know what S and T are, but I know that they're the same. So I'm just going to call them X. So if S is X, then T will also be X. And then we just get a regular linear equation. We combine like terms, we then use inverse operations. So I'm going to go ahead and give you a minute to look through this or solve this equation. So go ahead and solve that equation there. Do this inverse operation, so subtract 126 from both sides. And then you would have 2x equals something, and then you would just do the inverse, which is dividing 2 on both sides. All right, so hopefully once you did all the inverse operations that you need, you would get that the measurement of angle S is 117, which is what we just saw above. All right, let's go ahead and take a look at a trapezoid that is not an isosceles trapezoid. So we're not going to be able to apply the rule for isosceles trapezoid, which is that the base angles are congruent. So if I take a look at this here, all I know is that I have a trapezoid, which means I have two sides, and I'm going to outline them and extend them. I have two sides that are going to be parallel to each other, which are the bases. If I use my transversal, which is the diagonal SQ on the trapezoid, and I extend it more, then I get a very familiar diagram. So I get that those two angles that I marked are alternate interior angles, which means that they're congruent. So since we knew that the top right side angle was 30 degrees, then the bottom left side angle will also be, sorry, not 70 degrees, 30 degrees. Then the bottom left will also be 30 degrees. All right, so to find the measurement of angle 2, I'm going to outline this triangle here, right? So in this triangle, we know two of the angles. It would be really easy to create an equation to help me find out what the measurement of the third angle is. So in a triangle, if I add all the angles together, then hopefully you're saying that it should equal 180 degrees. And then we combine like terms, we do inverse operations, and then we find out what the measurement of angle 2 should be. So when I add those three angles, the sum is 180 degrees. There I showed you the whole process. So then we would subtract 115 from both sides, and we would get that angle 2 equals 65 degrees. And what did I do? Well, I added all the angles, so it's the triangle angle sum theorem. So a little different strategies we would have to use if we didn't know that we had an isosceles trapezoid. All right, lastly, we do like them when they're isosceles, like the one you're looking at right now, because we get some congruent angles or we get some supplementary angles. All right, so that just like the problem says, we have an isosceles and they marked it for you as well by showing that the legs are congruent. Okay, so angle A and angle C, because you have an isosceles trapezoid, the opposite angles are supplementary. So if I add angle A and angle C, it's going to equal 180 degrees. Substitute the values and we solve for angle C. And let's go ahead and justify here. I wrote that angle A is congruent to angle C, but later I'm going to go back and fix that. So they're not congruent, they're supplementary, just like we showed on the equation. And that's only because you have an isosceles trapezoid. All right, we're going to apply the same strategy that we did in the previous problem. Let's go ahead and extend the parallel sides and extend our diagonal. And we're going to use the measurement that we're given there, which is 50 degrees. So angle 1 will also be 50 because these two angles are alternate interior angles, and alternate interior angles are congruent. I don't know why I wrote some there. It's just alternate interior angles theorem. All right, same strategy. I have a triangle here. I know two measurements, so it would be really easy to find out what the measurement of the third angle is on that triangle that I highlighted in pink. Yep, that 50 should not be 51, it should be 50 degrees. All right, so after that correction, you know the drill. And again, we use the triangle angle sum theorem. All right, almost done here. We just need one more. Let me go ahead and erase some stuff here because I have too much highlighting, so it might be a little hard to distinguish the stuff that I'm trying to show you guys here. All right, so let me erase the highlighting. So we have an isosceles trapezoid, right? What do we know about it? We know that when we have an isosceles trapezoid, the base angles are congruent. That means that angle A will be congruent to angle B. We know part of angle B is 50, so the remaining part needs to be 20 degrees. So that together, it's 70, which is the same as the measurement of angle A. Not angle D, but angle B. And that's because base angles are congruent when you have an isosceles trapezoid. So make sure you have angle B on there. So A and B are congruent. And we came to switch this here. So remember angle 4, the way we found it was because angle A and angle C are both, their sum are supplementary. And that's it. That's how we apply properties for isosceles trapezoids to help us find some measurements